When we get to example 2, fractions scare people for whatever reason. But my process is still the same. Doesn't really change anything. In the first case, I have a coefficient of -5, and that square root of 108 is going to be the same as 6 root 3. In the second one, I have a coefficient of 3/4, and the square root of 8 is 2 root 2s, minus 5/4, and the square root of 48 is 4 root 3, and 1/2, and the square root of 50 is 5 root 2s. I'm going to multiply it out properly, remembering that I'm still just multiplying a fraction, so I can multiply the fractions out and then simplify them. And this is going to give me -30 root 3s plus 3/4 times 2 is 6/4, or 3/2 root 2s, minus 5 root 3s when I multiply that out, 5/4 times 4, plus 1/2 times 5 is 5/2 root 2s. Now I need to combine my like terms. Well, what are my like terms? I have a root 3 here. I have a root 3 here. So those two I can combine. I have a root 2 here and a root 2 here. So those two I can combine. What's that going to give me? Well, if I have -30 root 3s and -5 root 3s, I have -35 root 3s. If I have 3/2 plus 5/2, then it's 8/2, or 4 root 2s. And there's my final answer. When I get to the next example, same process, I'm just dealing with cube roots in this case. So the first one I can simplify. The cube root of 64, actually, it's just a perfect cube. That's going to be 4/8. Plus 2. The cube root of 375 is the same as 5 and the cube root of 3. Minus 2, and the cube root of 54 is 3. And sorry, the cube root of 2, all divided by 3. And finally, 5 and the cube root of 24 is the same as 5 and 2 and the cube root of 3 all over 2. I'm going to simplify my fractions, or multiply out my coefficients. So 4/8 is the same as 1/2. 2 times 5 is going to be 10 and the cube root of 3. 2 times 3 divided by 3 should leave me with -2 and the cube root of 2. And 5 times 2 divided by 2 is -5 and the cube root of 3. And then I'm just going to look for my like terms. I only have 2, a cube root of 3 and a cube root of 3. Which means that I have 1/2. I'm going to be left with only 5 cube root 3s and -2 cube root 2s. And at this point, I'm not too worried about the order, so don't worry if you put it in a different order than I did. All right. These are really popular when we're doing adding or subtracting with perimeter style questions. So when it says, find for me what the exact length of x is, because this shape looks like a rectangle that had a section cut out of it from here, and these are vertical lines, then I can assume, based on what I see, that this length is the same as a combination of these two lengths. Or that if I take this length and I take away this length, it's going to leave me with what my x length is. So I can say that x is equal to the big length, 8 root 2 plus 2 root 12 minus the small length, 5 root 27 minus 4 root 18. The reason I put it in brackets is because I know that I'm going to have to distribute that minus into both parts here, which is going to change the signs of both of these terms. So I can say that this is equivalent to 8 root 2 plus 2 root 12 minus 5 root 27 plus 4 root 18. Don't forget to flip that negative. I'm going to simplify all these. Eight root 2 plus 2 and 2 root 3 minus 5 and 3 root 3 plus 4 and 3 root 2. This is going to give me 8 root 2 plus 4 root 3 minus 15 root 3 plus 12 root 2. And we can see that we have like terms of root 3 and root 3 and like terms of root 2 and root 2. Which means that when I combine those, I'm going to get the answer to A, which is I have 20 root 2s and I have negative 11 root 3s. For B, where it says as a decimal to the nearest tenth, I can just put in 20 root 2 minus 11 root 3 into my calculator, and it rounds to 9.2. All right, that's it for adding and subtracting.